And
Go ahead, Viola.
Oh. Good evening, everyone. Thank you all so much for joining us tonight. First of all, my name's Yue Lan. I'm the volunteer with CAPA Nova, Chinese American Parent Association of Northern Virginia. We are a volunteer-based nonprofit organization dedicated to uplifting the voices and rights of Asian Americans, especially our Chinese Americans, in all areas of our lives. In the past year alone, we've organized almost 500 events, including seminars, workshops, covering a wide range of topics, anything you can think of. You name it, we have it, from education, community wellness, and then civic engagement, and so on and so forth. Tonight, we're so lucky, so excited to have invited two incredible brothers. I have actually had the chance to talk to them, and they're very impressive. These two brothers, they share the deep passion for chemistry, and tonight they will share with you, their passion. And also, end of July, two of them will jointly host 1 hour class, online class. You can check out the information towards the end of the session. They will post the QR codes. And whether you are a science lover or you are just curious learner to learn something new, tonight you are in for a treat. Before I turn the floor to them, I wanted to quickly introduce two brothers, Victor and Lucas Wang. Victor, older brother, congratulations, Victor, because he has been accepted by IB, which is University of Pennsylvania, and he's rising freshman this fall. And he is the top 150 in US NCO. For science lover, you probably already know. I had to Google it. It's the United States National Chemistry Olympiad. And he has been the president of Marshall High Chemistry Club, and he's taken honor IB organic chemistry. And he himself, and also aside from the science, he's also a marching band drum major. For those who don't know, they're the conductors of the marching band. They're the soul of the band. And he's also self-acclaimed foodie, and so am I. So he was gracious enough share with me some of his favorites in this area. And the younger brother, Lucas Wang, is a rising junior at TJ. His team placed 5 in nation in WUCT, which is Washington University Chemistry Tournament. I Googled that as well. He scored 40 out of 60 on US NCO, which is very impressive, the score. And he's officer of TJ's chemistry team. He's on TJ's Science Bowl team, and himself is very experienced saxophone player. And by the way, Victor also plays saxophone, and Victor is a jazz composer as well. And last but not least, Lucas is an animal lover. He said he loves guinea pig. All right, without further ado, let's welcome Victor and Lucas.
Thank you. Hi, everyone. I'm Lucas.
And I'm Victor. Today, Lucas and I will be giving you guys an introduction on various fun chemistry topics, like their applications in the real world, as well as like tell you guys about like competitions that we did, as Miss Yue mentioned. And we will also be giving you guys all sorts of different content, whether you're like just new to chemistry or have a little bit of experience. This presentation is perfect for you. So this is a quick overview of like the various things we'll cover this class. We'll first like introduce like the various like goals. We'll go over like a quick introduction to chemistry. Then we'll quickly go over like the certain like contents that we're gonna cover in this class. Because this session is an introduction to our 5-class series later in July. And we'll also go over the class schedule. And finally, we will give QR codes if you guys are interested to sign up for our class. And at the very end, we'll have a little like fun quiz, so make sure you guys pay attention. So our objectives of this class is to engage students with captivating lessons, like make sure that you guys understand like the essence of chemistry, and like allow you guys to kind of gauge whether this science is for you or not. And we also want to help you guys like thrive in your high school chemistry courses and do well in them, as well as like if you want to take it a step further, go through like prestigious chemistry competitions that you guys can get involved in, stuff that you can use to prove your chemistry prowess. So as for our target audience, if you are from fifth grade, like which is like late elementary school to like early high school, which is ninth grade, then this class is very perfect for you guys. And the purpose of this class, again, we want to gauge an early interest for you guys in chemistry, to see if you guys want to pursue this later on.
So for my experience, as Miss Gia mentioned, I'm a rising junior at TJ, and my team placed fifth in the nation in the Washington University Chemistry Tournament. I also got 48 out of 60 on the Chemistry Olympiad local exam. And I'm also an officer on TJ's chemistry team. I'm in TJ's science bowl team, and I've taken honors in AP Chem, and I'm planning to take organic chemistry next year. So for why I got interested, a lot of my friends actually were interested in chem, and I actually had a fun time like interacting with them, which led to my passion in chem. I've also done a lot of labs at TJ, which were also very interesting and cool, and that really got me interested in chem.
And as for me, I'm a rising freshman at UPenn. As for like the things I did in high school, I was top 150 in the nation in the National Chemistry Olympiad. I was also co-president of the Marshall High School Chemistry Club. And as for courses, I've taken the highest IB course offered at Marshall, IB Chemistry Higher Level. And I also, since I finished the hardest course at Marshall, I went to a local community college to take Organic Chemistry 1 and 2. As for why I got interested, funny story. I used to like really not like germs. And like once I like started like getting into chemistry though, or like getting introduced to it, like in my honors or IB advanced chemistry class, I started realizing that like all these like scary germs were just like I started thinking of them within like the molecular sense, like calcium, sulfur, magnesium. So like they actually didn't seem that scary anymore. And that really got me like hooked in chemistry, along with the class and like touring labs. I just knew that chemistry was right for me. And my passion got further accelerated through like doing chemistry research at George Mason, which is what I'm actually doing this summer as well. So here are some fun facts about chemistry. When we have various different ions as shown in the picture on the right, you can see lithium, sodium, potassium, calcium, and copper. And the cool thing is that when these different ions are like held up to a flame, the flame actually produced by them turns into different colors. So lithium is a red flame, sodium is a yellow flame. And then for the last three, they're actually colors that like you might not see that often. And that's actually due to like the ions that are being put under the flame. So that's just a really cool way of like visualizing and like seeing what certain ions are in the solution. Now going into like states of matter, we see on the bottom, we can see a diagram of a lake. And the reason I'm showing this diagram is, as you can see, the top layer of the lake is fully covered with ice. And because of that, like the fish are able to survive under the water. And if the only reason the ice can like stay on top is because the solid form of water, which is ice, is less dense. And that means that the ice is going to float above the water, and that's how the fish can survive. Because if the ice was more dense, then it would sink or it would freeze over the whole lake, and that would not be good for the fish. The next fact that we have is certain rare metal elements like palladium. They can go up to $1,032 per ounce. That is a crazy amount of money, and that really goes to show like how much these rare earth elements pose a value to our society and how chemistry can help with that. And finally, lemons actually have more sugar than strawberries. You might not expect that, but it's just that the lemons have citric acid, which overpowers the sweetness that they have. And citric acid is very powerful in interacting with your taste buds. So if you go into that, you will realize why lemons are actually they actually have more sugar than strawberries, but they're less sweet. All right, so our course covers many of the major topics in high school chemistry. Again, we're mainly going through this course. One of the main goals we have in this course is to make high school chemistry like a little bit less intimidating. So we are going to go through like various cool visuals, fun activities, and overall like connect it to real world applications that you guys can visualize and that you guys can see in your real life. So yeah. So we will start with like the various like content topics that we'll go through really quickly in our class. We're not going to go into like the nitty gritty, but we're just going to give a brief overview so you guys can like gauge overall what our class is going to look like. For day one, we will have chemical calculations preview. So this is going to go over many of the very foundational principles that you guys will learn basically as soon as you step into like your high school chemistry class. And these tools are moles, dimensional analysis, and basic stoichiometry. Excuse me. So these things are going to be very foundational in other topics as well. These are as I said, these are the base of chemistry. So here I'm gonna go over just really quickly just a preview of like moles. So as we know, 1 dozen is like a unit, like a dozen of eggs. And what 1 dozen means actually is that it means there's 12 things. And just like a dozen, a mole is also a unit. Just like you say a dozen of eggs, you could say like a mole of eggs. But the thing is, a mole is an extremely large number. It's 6.022 times 10 to the 23rd things. And the reason we have such a large number to describe like a unit is because chemists often use like moles to convert to grams and grams to convert to moles. So if you have like 1 gram of a substance, that's gonna be like more than like billions and billions of atoms. So that's why we have such a large conversion unit between like the tiny, tiny atoms and like 1 gram of a substance. So just like a dozen, a mole is a unit. So just to make sure, guys, it's not the animal as shown on the right. Please do not get it confused with that. So here's dimensional analysis, which is another very key tool in chemistry. It's used in many chemistry problems, and it's a method to convert between different units, as I alluded to before. Let's say you want to convert like inches to centimeters. We're going to use a railroad tracks method, which is shown in the image at the bottom. You can see the given amount, the conversion factor, and the end amount. And we see that the starting point, let's say we want to convert 32 inches into centimeters. So we give the 32 inches, we write that out first, and then we write the conversion factor. This is the key step in this problem, which is 2.54 centimeters equals to 1 inch. So
Why not? It's like, it seems like pretty obnoxious.
The
Wait,
audience, please mute yourself. Thank you.
wait, guys, can we save the questions for later? We have a
Yes,
dedicated
yes.
section for Q&A.
Right, I noticed we have some questions. Yeah, we will have a question and answer session, but you guys can write in the box. Go ahead.
yeah. And just to like remind you guys, like don't worry about like knowing every single like piece of knowledge that we're going through right now. It's mainly like a preview about like how our class is going to be structured. But just try to pay attention if you can. Just don't obsess over like getting every single detail. So yeah, we'll go along with the conversion factor, which is 2.54 centimeters equals to 1 inch. And you can see that you can cancel out the inches. You're gonna put the inches on the bottom actually because you want to cancel out the top and the bottom. And then the only unit you have left is the centimeters. So you can move that centimeters to the right. And 32 times 2.54 is 81.28 centimeters. And yeah, this method allows you to easily organize your units when you're just converting between them. So here's an example. Let's say you have, we want to convert from a dozen to how many eggs that you have. So the problem is you want to convert 2 dozen eggs into how many like actual eggs are there. So right here, we're starting with the given, which is 2 dozen eggs at the very left. And in the middle, we have our conversion factor. We know that 1 dozen eggs is equal to 12 eggs. So we're going to write that conversion factor. We're going to have the dozen eggs part in the very bottom, so we can cancel the units out as shown here. So now you can see the orange slashes. We're canceling out the dozen eggs part, and we're able to have the eggs, the 12 eggs on the top as the actual unit. And overall, 12 times 2 is going to give you 24. And yeah, that's how dimensional analysis works.
So next, we're going on to day 2, where we're gonna talk about atoms and bonds. So as you can see, these topics, we're gonna cover like our atoms, radioactivity, bonding, and periodic trends. So in summary, these topics talk about how elements are like built and how they react with each other, and it forms the foundation for like understanding how they would interact with each other and how they would form different materials. So first we have the atom. So the atom is a very small particle that everything is made out of. So look around you, like everything you see is made out of atoms. So let's say the computer I'm looking at right now, there's silicon in it because the computer uses silicon as a semiconductor to power it. Uh, the atom also consists of even smaller particles, like protons, which have a positive charge, electrons, which have a negative charge, and neutrons, which have a neutral charge. So, to explain how the atom was built, many scientists proposed different models that improved over time. So, the first model was proposed by Dalton, and it was a solid sphere, as you can see in the bottom left. So basically, he said the atom is just a solid sphere, which is pretty simple. Next, we have Bohr, who proposed a planetary model where there's a positively charged center with electrons orbiting around it, as you can see in the rings. Lastly, we have Schrödinger and Heisenberg, who proposed the electron cloud model, which is the most advanced model we have today. And it involves a positively charged nucleus in the center, as well as electrons around it in a cloud kind of shape. There are many more models, however, they were not included there, but they're all important, and we're going to talk about them in our summer course.
随便不要就不要。
These models help us visualize how atoms move and interact with each other in different ways. So another big part of chemistry is periodic trends. So when chemists need to predict the properties of elements, they would look to the periodic table and find patterns. So for example, a pattern would be size, right? So down a column in the periodic table, size would increase. This is because electron rings of each element would stack on each other, making the entire element bigger. So think about Russian nesting dolls. I know this is kind of a unusual example, but as you put the next shell on top, it will become bigger, as you can see in the picture from the right to the left. Size is only one of the periodic trends in chemistry, and we'll cover more in our class. So bonding. Bonding is one of the ways that atoms interact with each other. So there are three types of bonds. First is covalent. So this is where atoms share electrons in a pair. Think about it this way. There's two students. One student has a red crayon and the other has a blue crayon. If they did covalent bonding, they would share both crayons so they can use both the red and blue crayons. For ionic, one atom would take the other atom's electrons and uh, the other atom would lose their electron. So in our example with the crayons, one child would take the crayon from the other person, so only they can use both the blue and red crayon. Lastly, we have metallic bonding. So this is where atoms share electrons in a group, and this shared electrons are called a sea of electrons because they surround the positively charged atoms. So these electrons act like glue between the elements and they would stick together and form something like a metallic alloy. So for day 3, we're talking about matter and reactions. So the topics we're going to talk about are states of matter, ideal gas law, and chemical reactions. So these topics show how matter has different forms and how they would change between those forms. They're also going to talk about how these can create new materials or new like states of materials. So first, we're going to talk about states of matter. So there are multiple states of matter, but the common ones used in chemistry are solid, liquid, and gas. As you can see, for water, solid water would be ice if you left water in the freezer, right? And liquid would just be room temperature water, and gas would be water vapor if you boiled water. So that's like the steam you see coming off the water surface when you boil water. So here we have a video where water is shown in these three states at the same time. Let's see it. And don't worry about knowing what triple point is. The point of this video is to show how at these three states can stay in the same time. Okay, so as you can see, there's a piece of ice floating in the middle, and in the water, this is actually in a vacuum chamber where they're controlling the pressure and the temperature, and this helps them manipulate uh, the water so it can exist at three different states.
Mm.
So in this video, you can see that the ice is still there, but the water is actually boiling. Like you can see by the bubbles, those are actually just gas molecules of water um that occur when temperature changes.
Mm. Mhm. So cool.
Yeah, so this is just like a special point where the water can exist in all three states. It's a rare exception to like what we see in like daily life. But it is something cool in chemistry. You can see like the ice, the liquid water, and like the bubbles, which are the gas. They all exist at the same time.
Mm. Mhm.
Uh, Continuing on. Reactions. So reactions show how elements react with each other and they make a completely new substance. So signs of a reaction include a color change, formation of a solid, production of some gas, release of heat or light, or a change in smell or odor. So reactions are actually used in the production of many things like fertilizers or uh, anything you use in daily life, it's basically made by a chemical reaction. So here we have a video showing how precipitation reactions look like.
"他们在弄化学了，你看。
Alright, so continuing on, day 4 is talking about energy and equilibrium. This is one of our most hardest days of our course because it covers some complex topics. This includes thermodynamics, kinetics, equilibrium, and acid and bases. So these topics explain how energy, speed, and balance affect chemical reactions. And it also explains how some real life things works, like batteries or how our stomach acid dissolves food or how it stays in check. So for equilibrium, it is defined as when the rate of the forward reaction is equal to the rate of the reverse reaction. So let's say I have a reaction where 1 is in equilibrium with 2. So if it was at equilibrium, production of 1 would equal the production of 2. And the amount of 1 and 2 at this point would stay relatively constant. However, there's going to be tiny changes in 1 and 2. One big principle of equilibrium is called Le Chatelier, and it's used in many real-life scenarios. One big case is used for fertilizers, where they actually produce a very important compound called ammonia, and this uses heat and to better produce some fertilizers. So here you can see it creates some cool visuals in this video.
The conversion of red-brown NO2 to colorless N2O4 is an exothermic reaction. We're going to use Le Chatelier's principle to predict the shift of the reaction with respect to temperature and also the color. Because this reaction is exothermic, heat is a product. Therefore, adding more heat to the reaction will shift it towards the red-brown reactants, the NO2. Placing the other tube in cold water is the same as removing heat from the reaction, so removing a product. That will result in the conversion of NO2 to the colorless N2O4.
So as you can see in this video, the thing in the test tube actually changed colors. As you can see by the difference in colors in the test tube, one is brown and one is yellow, just because they made the solution more hot or more cold. So another topic in day 4 is electrochemistry. So electrochemistry is studying how electricity and chemical reactions work together. So basically, in some reactions, electrons are lost. And some reactions, electrons are gained. So these reactions are coupled together so they can generate electricity by moving the electrons through the wire, as you can see in this diagram. And this movement of electrons creates electricity that can power light bulbs. So one example of electrochemistry's use in real life is batteries. Okay, now we're gonna create a quizzes where we're gonna test everybody on what we learned today in this presentation.
So audience member, if you know the answer, you can just unmute yourself and shout it out, or you can raise your hand. We'll just call on you.
Yeah, I am gonna share the screen right now. So everybody, you can enter this link and join by typing in the code, or you can scan this QR code.
Yeah, we'll just give you guys 1 or 2 minutes to join, then we're going to start.
Is this like the Kahoot?
Yeah, it's similar to a Kahoot. We're gonna go through the questions and everybody has a certain amount of time to answer. And at the end, we'll show the leaderboard and see who did the best.
Oh, I see. Okay.
Looks like we have 2 people already joining. Yeah, we'll give you guys some time to start joining. Yeah, while everyone is joining, I'll just talk really quickly about like certain tools we're gonna use in class. We're gonna use various tools like quizzes, as you see here. We're also gonna use like Kahoot, beautifulchemistry.net, YouTube demos, and interactive simulations, like FET And we're gonna like use a lot of these different resources to keep chemistry engaging for you guys, and to like let you guys sort of interact with it just in a lecture style format. So be on the lookout for that when you guys take our classes. It's gonna be very great. All right, we'll give you guys 30 more seconds to join, then we're gonna start our quizzes.
I guess we'll start now. Right.
This is a dimensional analysis question that I went over in the earlier slides. All right, looks like most people got it correct. That's good. Next question. Jonathan and Jack on top. Okay, let's continue.
Okay, so that question was based on periodic trends. As I mentioned, like there's a periodic trend with size, and size increases down a column. So good job, everyone who got it correct.
Oh,
Whoa.
everyone got that one correct. Good job to Jonathan and Jason and Eric, I believe, on the top. This one is a little tricky, guys.
Whoa. Jonathan, Jason, and Lele. Nice. Yeah, this question is about one of our more complex topics, which is equilibrium. So I'm surprised most people got it correct. So good job. Mm.
All right, one more question.
Oh, seems like Jonathan took home first place. Congrats.
Good job, Jonathan. Seems like he really understands chemistry. And that really just goes to show, like the intuitive nature of it. Like, it's really like beautiful. It's a really beautiful science when you truly understand it, and when you understand the logic behind it. And that's what we're gonna try to promote through our class. So we're gonna go back. Congrats to our top winners. And yeah, we're gonna go back to our slideshow and present it. Yeah.
Okay, so as we mentioned before, we use these things to help you learn and keep our classes more engaging.
Yeah. Yeah, if our slideshow is not showing, make sure to let us know. But yeah, we're gonna continue with the slides. So now the part that some of you might be waiting for are like the competitions. So if you've gotten to a level where like you feel like you truly understand chemistry, like you really enjoy it and you just want to have a lot of fun and compete with other people, we are going to go over various like competitions a lot of strategies that you can take to really excel and score in like the top of the top later on. I know this is still an early stage, but this is like a long-term goal that you guys can look forward to. And let me tell you, just from experience, it's been a really fun time. I've had so much fun like studying, preparing, and just learning about different chemistry topics in these competitions.
Yeah, you also make a lot of new friends. So,
Yeah. So some different competitions that I want to introduce to you. The first one is the USNCO, which stands for the US National Chemistry Olympiad. Now both me and Lucas have done this. I progressed to the national level and earned top 150 in the nation. Um, and in this competition, it's a solo competition, which means that you yourself need to be pretty like
Stop it, or else no pizza. And you sleep.
yeah. If everyone in the class, please make sure to mute. And yeah. So the USNCO is a solo competition, so you have to be really fluent in chemistry yourself. But it's something that's like it tests like high school and beyond chemistry. So it's pretty complex, but in our class we hope to introduce certain topics in the USNCO. And we'll also go over the WUCT, which is a chemistry tournament hosted by Washington University in St. Louis. And this is like team-based competitions. And these are very like creative types of like um, organizations of chemistry. And in these like various tests in the competition, you guys will be exposed to like various different real world applications of chemistry. So if you are interested in these competitions and potentially earning awards in them, be sure to attend our classes in July because like especially if you're like a fifth to ninth grader, this will give you like an early start to preparing for these sorts of competitions.
okay, so here we have a competition question from USNCO. So this is a pretty simple question, but let's walk through it together. So here we have the question, how many nitrogen atoms are present in 486 grams of N2O5? So for this type of question, it's mainly testing on your ability of dimensional analysis and calculating molar mass, which is the amount of grams you have per mole, which we mentioned was used to convert between atoms and grams because we need a lot of atoms to have some sort of mass. So for step one, we're going to find the molar mass of N2O5. So in the periodic table, it shows that each element has a certain mass per mole of that element. So for nitrogen, it's 14 grams. For oxygen, it's 16 grams. And by adding up all the elements in this compound, N2O5, by doing 2 times 14 for nitrogen's mass and 5 times 16 for oxygen's mass, we get 108 grams per mole, which is the molar mass of N2O5. Next, we'll use dimensional analysis to convert these grams into moles of N2O5. So as you can see here, we're using the railroad tracks method. So we first put what we have or what is known, which is 486 grams of N2O5, and we use the molar mass as a conversion factor to convert between grams and moles of N2O5. So by doing this, we can cancel out the grams of N2O5 and we're left with moles of N2O5 and we get 4.5 moles. But we're not done yet. So step three, we're going to use dimensional analysis again to turn these moles into atoms. So as you can see, we put our 4.5 moles in the top left, and then we use the conversion factors of moles, which is 6.022 times 10 to the 23rd, as you all know from that quiz. I think everybody got that question right. So yeah. So we can cancel out moles of N2O5 in the bottom and the top, and we're left with the molecules. So we get 2.71 times 10 to the 24th molecules of N2O5. So the last step is to use dimensional analysis again to convert N2O5 to N. So first we start off with the number we obtained in the last step, and we use the conversion factor of 1 molecule of N2O5 to 2 atoms of N. We use 2 atoms of N because in N2O5, there are actually 2 nitrogen atoms. So this is a place where a lot of people would get tricked and they would put the wrong answer. So the correct answer, which we got, is 5.42 times 10 to the 24th atoms of N. So as you can see here, it matches quite answer choice C. But if we did not multiply by 2 by that conversion factor, we would actually get B, which is the wrong answer. And a lot of questions in this competition will actively try and trick you with plausible answer choices. So yeah.
All right, so moving on, here's the schedule again. So our classes will be late July to like early August, as you can see. Our classes are from 8 p.m. to 9 p.m. In Eastern Standard Time. This is a pretty friendly schedule, especially to I think one of our attendees mentioned that they'll be visiting China. This will be like a decent time for those in China as well. It'll be like early in the morning. But yeah, this is very friendly. You can join on Zoom from different countries, even if you're traveling, right? And we'll also be going over the various topics that you can see on the slides. We went over it really quickly today, so you guys can just take a screenshot if you want. I know it's been like a long time today that we're lecturing, so I'll end off this class with QR codes. So you guys can scan this on the code on the left for our course overview, like a broad summary of our class. And on the right, this is the QR code to sign up for our class. So if you guys think that you were amazed by any of the things that we said today, we really do encourage you guys to sign up. And yeah, the right-hand code is a form that you can fill out to sign up to our class. And we will send you guys the Zoom link after you sign up. And yeah, thanks for listening, guys. We really hope you enjoyed. Yeah. Do you guys have any questions that you guys want to ask us?
Yes, I see there are some questions posted in the chat box already. Before we have two of you start entertaining these questions, I want to just quickly give you guys a shout out. You know, what a great job. I'm not a STEM person myself, and I feel like I've learned so much myself. And then you made chemistry so interesting. And one of the things I love about you guys, you make some hard concept easier to understand. You put them in simple language, and then you give very vivid examples like crayons and Russian nesting dolls, and I love all those examples, and it left me very strong impressions. And then both of you are so delightful. You know, you wear big smiles that put smiles on our audience face as well. So I'm sure you'll be great teachers and presenters. Before, I wanted to spend 2 minutes quickly talk about, because one of the questions I wanted to address is, Ethan, you said, I apologize, joined late. So is there any way for me to obtain a recording? That's a great question, because we are a volunteer-based nonprofit organization. Like I mentioned in the beginning, in the past year alone, we've hosted almost 500 seminars, workshops. Many of their recordings are available online. And then we do have, I wanted to just quickly post our, link to our membership, and then we have different levels. Let me just quickly find it. I want to just post it here, and then you can just sign up, become our member, and then you can have free access to everything. I wonder whether, okay, is it file? Maybe, okay, how about this? I don't want to waste too much time. How about Lucas and Victor, you guys start going through the questions. You can answer them. Meanwhile, I will find the link and post them here. Okay, for those who are interested. Yeah, go ahead.
All right, so for the first question we see, for people who want to take chem competition, which grade should they take organic chemistry?
Yeah, so for the USNCO, which is like the largest chem competition in the US, organic chemistry it is correct me if I'm wrong, it's like 1/10 of like the questions. It's around like 6 questions. So like it's not gonna be like in your early stages, it's not gonna be like too important as it's only like 10% of the entire test. And since it's like an advanced topic, I don't think it'll be covered too much in AP chemistry. So like overall, I would say that you guys should try to be exposed to chemistry, organic chemistry in like 11th or 12th grade. Um, but it depends on like your school and what they offer, because some schools don't even offer organic chemistry. So there are some like online services that like or a lot of online resources and textbooks that you guys can check out to get exposed to organic chemistry on your own, which is what I actually do recommend because a lot of schools, again, they push off organic chemistry to like your later grades.
TJ, I see.
Yeah, TJ has organic chemistry, which
Mhm.
Lucas is actually going to be taking next year as a junior. So if you're going to TJ, that's a really great resource that you guys should definitely try out.
Alright, so for the next question, what is the cutoff score for USNCO local? So it actually varies by school. So my school, TJ, has a very high cutoff because all the students there are very competitive. So I think this year is like 55 out of 60, which is like really unheard of. Like it's like pretty high. And for my brother's school, Marshall, like more typical base school, it's around like
Yeah, I mean, it's
how
like
much?
I'm not sure the exact like data because they don't necessarily release it, but like based on like my general like assumptions, I would say it's like early 40s, like 40, 41, 42, 43. I scored high 40s, so like I ended up qualifying for the national exam. How should you prepare for the USNCO exams? First of all, you guys should definitely take our class, okay? Because we are going to be going a decent amount into USNCO, and because we want you guys to like enjoy the same amount of competitive spirit in the exam that me and Lucas did. And otherwise, there's a ton of like online resources like classes, textbooks, and even your like classes in school. They're gonna prepare you well, especially AP chemistry and beyond. And yeah, there's online communities that you can also join. There's a lot of like very strong online communities. You'll meet a lot of friends there, and yeah, I really do encourage that.
Okay, so for how much did this class cost? So this class cost $50 for all 5 days. So that's basically $10 per day. And
Not
uh
for you guys. It's
not
for non-profit.
yeah, it's
Yeah,
not
the profits don't go to us. It's for the nonprofit that's like hosting us.
Mhm.
And yeah, it's just a fee to like help them continue like supporting these types of classes. So yeah, to answer your question, it's $50
Yeah.
for 5 days. So only like $10 per class. So hopefully you guys can make it. If cost is an issue, please make sure to communicate with us. We're willing to be flexible and accommodate all sorts of different people. And yeah, any other questions?
Feel free to unmute and just
Yeah, feel
ask.
free to just unmute and ask if you want. I see another question for students who took Algebra 1, is it sufficient to take your class? That is,
So, Victor, sorry to interrupt you. Could you on share so I could quickly share because I don't know how
yeah.
to attach a file here. Okay. All right, thank you.
Mhm.
Oh,
Oh,
thanks a lot.
yeah, so to answer your question, people who took Algebra 1, it should be enough for our class, but for some competitions, you may need to have some pre-calculus knowledge. So, yeah.
I mean, no, because for competition chemistry, like you should have Algebra 1 or higher. But like for our class, it's mainly like to introduce you guys to chemistry. And like Algebra 1 is way more than enough to like attend our class. Like our class stretches from like 5th grade all the way back to 5th grade to 9th graders. So really it's a way to just get you guys in the door in chemistry. So yeah, Algebra 1 is way more than enough. Even if you haven't even taken middle school math, that's way more than enough for our class. The next question is,
Do you
if
provide any material?
if aiming for competition, which grade should you start learning chemistry?
So I think it depends because some people, it might take them a little longer to understand some concepts. Like I heard of some people who only studied 1 year, but they studied really hard and they made it into like top 150. Um,
Yeah, but
like
there
they
is no
could,
limit. There is no limit to when you should start learning chemistry. Obviously, the more you learn chemistry, that's never a bad thing. All right. And like just being exposed at a younger age, I know a lot of people who even started like in middle school or elementary school, and those people are some of the most successful in chemistry Olympiad as I've been talking to them. So yeah, and I see most people start. I would say that many people start like early in high school because that's like when you start actually taking the classes
Mhm.
and systematically trying to learn chemistry. But our class is another way to like learn chemistry by organized by different topics. So we really do recommend that you guys sign up.
Okay, so the next question is, do you provide any material for the class? Um, yeah, we're providing the slides and the different activities, but other than that, no. Okay, so
Yeah,
any
we
other?
will also like provide like lots of like interactive resources like Kahoots, simulations to allow you to visualize a lot of things. And we'll give you like lots of links so you guys can like further gain enrichment from that apart from our class. Because 5 hours, while we do want to help you guys as much as possible, we do have limited time. So yeah, we will provide you with as many resources as time allows. So yeah, thank you guys so much. Again, if there's
No,
any questions, feel free to unmute right now.
can you guys see this page, the membership drive? So
Yeah.
you can see it, right? So basically there are different levels, and then so most basic level is the first one. And to become a basic level member, and you can have access to all the video recordings. But if you want to, like myself and many of the volunteers, we're lifetime members. So you're more than welcome. And if you're a business, and you're also welcome to become the business members. So this is the only way we sustain our organization and try to represent our Chinese American community in this area. We also do a lot of the advocacy for our community, and we organize all these kinds of seminars and workshops. So I'm going to stop sharing, and Victor and Lucas, why don't you guys bring up the last page of your presentation again, like the QR code, in case any of the audience member who come in late haven't had a chance to scan that.
Sounds good. Sounds
Yeah.
good. You guys can also take a screenshot of this presentation or of just this slide if you want. So you guys can get like the QR codes for later if you decide to sign up later.
And this recording will be on our website as well.
Yep, sounds good. Yeah, we really encourage you guys to yeah, thank you so much to this organization for hosting us. We really encourage you guys to support CAPA Nova as well. And Miss Yue, thank you so much.
Of course, yeah.
And
Thank you
yeah.
guys and for your time, both of you. And then best luck to your school.
Yeah, we really enjoyed presenting today. Any final questions, make sure to unmute yourself. But other than that, I think we're wrapping up. Yeah, thank you for coming.
All right. Thank you. Thank you, everyone. Have a good night.
Victor, Lucas. Good night, everyone.
Yep, thank you.
No problem.
Have a good day, everyone.
Bye-bye.